Hello children, how are you all? I hope all of you are fine. So we are ready with our new video. So before that, let's do some warm-ups, right? Okay, snap your fingers. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's begin. Now children, we are starting on with class 9's number system part 3. Okay, now till now you have learnt about what is rational number, irrational number, how to plot them on number line, how to do different decimal expansion and all those things. Now today we are going to start by representing rational number, irrational number on a number line in a geometrical way. Okay, now suppose you are given a number x, okay, root over x to represent on a number line. Okay, geometrically, okay, number line geometrically. So whenever you are given a number, first you need to consider that number as rational. So if you consider that number as rational, let us take it as x, okay. Now you will draw one line, okay, measuring the x, okay. Let that be A, B, okay. Let that be AB, okay. Now from B you will be taking one unit distance, okay. This much is x and here you will mark it as C. This will be unit distance, means 1, okay. Now what is the total this length, what we can consider? This will be total, this will be x plus 1, right? This much is x, if this much is x, then and this one is 1, then total it will be x plus 1. Now taking x plus 1 as the diameter, how much will be, if x plus 1 is the diameter, what will be its radius? Radius will be, if we consider radius as r, then we can say that x plus 1 by 2 means only the radius of this length, okay. And using that radius we will be drawing one semicircle, okay. Using that radius we will be drawing one semicircle, and from the point B we will be drawing one perpendicular, okay. What is perpendicular? Perpendicular means a line which is 90 degree on another line, okay. So if we draw one perpendicular, let us name it as D, okay. Let us name it as D, and let the midpoint of this diameter be named as O. Now if this is the radius, okay, that means this is the arc of the this is the arc of the circle, okay. So from here if I draw one line to D, from O to D, okay, it will be a straight line, okay. If I draw one line O to D, then what will it be? If this is the radius, O is the center, then this also will be the radius. So this one will also measure x plus 1 by 2, right? What will be this one? OB. OB will be, the whole length is what? X plus 1, right? From there if I subtract this x portion, okay, what will remain? OB portion, right? So it will be x minus x plus 1 by 2, which means x minus 1 by 2. X minus 1 by 2. Correct? Now, if I need to find this length, what I need, this is a perpendicular. Okay, I have got OD, I have got OB. Okay, this length also I have got. Now I need to find this length. Okay, this is very easy to find because by Pythagoras theorem we know that by Pythagoras theorem BD square will be what? BD square will be OD square minus OB square, right? If I consider this as a triangle, okay, right angle triangle, then I can apply Pythagoras theorem on it. And this one is the radius. We have considered whole thing as a diameter, x plus 1. Okay, x plus 1 by 2 means the radius of the circle. So radius of the circle, if this is the center, from here if I draw a line, then this also will be the radius of the circle, and this also will be x plus 1 by 2. Okay, now if I draw a perpendicular, then what it will come? This is coming as a triangle. So this length I know, this length I know. Will it be difficult to find this length? Of course not. Okay, so this will be x plus 1 by 2, right? X plus 1 by 2 minus x minus 1 by 2, right? And when I solve it, what do I get? I'll get, see, this is whole square. Okay, so you need to break according to the formula. So it will be x square plus 2x plus 1 minus x square by 2, right? So it will be x square plus 2x plus 1 minus x square plus 2x minus 1 by 2, which means okay, which means 4x by 2, or we can say this is x. So this length, this BD square is x. Okay, so what will be BD? If BD square is x, if BD square is x, BD square is x, so BD will be what? Root over x. So this length is root over x. Understood? Now taking B as the center of the number line, I mean taking this as the center of the axis, if I consider it as 0, and this one if I take the length, and if I draw an arc on the number line, okay, if I draw an arc on the number line, then the point that I get, that is my root over x. Understood? Now next we are going to consider, we are going to see how we can operate these irrational numbers and how we can operate rational numbers. Okay, now few things you should keep in mind while starting the operation of rational and irrational number. First thing is that if you are given one rational number, okay, if you are given one rational number and one irrational number, one rational number along with one irrational number, okay, and you are told to do some operations. Now what can be these operations be? Like addition, subtraction, multiplication or division. Okay, when a rational number is operated with an irrational number, the result whatever will come, it will be an irrational number always. Okay, when a rational number is operated with an irrational number, the answer will always come as irrational number only. Okay, second thing is that if you are given one irrational number to be operated on, okay, with an irrational number, okay, when an irrational number is operated with an irrational number only, the answer will come as, it can come as rational also, it can come as irrational also. Okay, the number outcome of the operation may be rational also, may be irrational also. Understood? So let's see with example how it comes. Now let's solve some of the problems. Suppose I have been given one number as 5 root 2 plus 3 root 5. Okay, and uh, 3 root 5, no, not 3 again, 6 root 5 minus 2 root 2. Okay, and you are told to add these two numbers. Okay, operation here will be add. Okay, and you are told to add these two numbers. Okay, what you will do? First, you will write the first number that is given, first number that is given. Okay, and as it is addition, so you will put the operator, okay, in between them. Then you will put the second number, sorry, correct? Okay, now we will, now this is very difficult. We know that if it was 5 plus 6 it would be easy, but now 5 root 2, 3 root 5, 6 root 5 and 2 root 2. Okay, what we will try to do, we will try to group the like roots into one section and the other into another section. Okay, so let's try. So it will be 5 root 2 plus 3 root 5 plus 6, you know, plus are plus, and plus minus means minus 2 root 2. Now this 2 root 2 and 5 root 2 we will be grouping together and we will be taking root 2 common. Okay, so we may write 5 root 2 plus minus 2 root 2, and what remains, see here also we can take root 5 common. Okay, so we need to group them or club them together. So root 2 we are taking common. What remains? 5 minus 2. And here we are taking root 5 common. So what remains? 3 plus 6. Correct? Now it is easy to operate. 5 minus 2 means what? 3. So 3 root 2. And here 6 plus 3 means what? 9. So 9 root 5. This is your answer for this question. Got it? Similarly, instead of this addition, if here my question was subtraction, okay? If my question was subtraction, then what would have I done? Okay, subtraction will be what? This number to be subtracted from that number. That from, suppose it was given, subtract this number from this. Whenever from is given, that number will be written first. Okay, and instead of plus sign, I'll be putting the minus sign, and same operation will go on. Let's see how. It will be 6 root 5 minus 2 root 2 minus, from is given, no? So this will be written first and then the next one. 5 root 2 plus 3 root 5. So again we'll be clubbing together. So 6 root 5 minus 2 root 2 minus 5 root 2 minus 3 root 5. Okay. It will be 6 root 5 minus 3 root 5 minus 2 root 2 minus 5 root 2. Understood? Next, root 5 will be taken common. So it will be root 5 6 minus 3. And here minus 2 minus root 2 I am taking common. Okay. So it will be 2. If I take minus common, then it will be what? Plus. Because minus into plus is minus. Okay, whenever you have a confusion that this what should I take, what should I, you just take a sign and just see that you can, when you multiply, it will come to its original sign or not. Okay. Okay. Then what it will be? 6 minus 3, it will be 3 root 5. And 5 plus 2 is 7. So, minus 7 root 2. Understood? Now, next let us see about multiplication. Okay. Suppose I am given one question. Multiply 3 root 3 into 2 root 3. Okay. I am given one question. 3 root 3 into 2 root 3. What it will be? See. Here also. You see. 3 root 3 means what? 3 into root 3. Correct? So I mean write like this. 3 root 3 into 2 into root 3. Okay. 3 2s are what? 6. And root 3 into root 3 is what? 3. Okay. So it will be 18. Okay. Now, next question. Suppose I am told to multiply. See, one thing you see, this is an irrational number, this is an irrational number. When I am multiplying two irrational number, I am getting one rational number. Okay. But here we can see one rational number and here it is another irrational number. So when I am getting this, I am getting one irrational number only. Understood? Now next problem. Suppose I am given 5 root 2 into root 3. Which means what? 5 into root 2 into root 3. Now can this be solved? No. So we will simply write 5 root 2 root 3. Understood? Now let's do some division operations. Okay. Now if I am given one number like 8 root 5 divided by 2 root 3. Okay, 2 root 3. Okay, how to do this type of divisions? Okay, now what we will write, 8 root 5 by 2 root 3. Okay, this means what? 4. So my answer will come as 4 root 5 by root 3. Okay, now suppose here it was, instead of this it was root 6. Okay, then here I could have written, instead of 6 I may have written root 2 into root 3. Okay, because 2 into 3 will make 6. Okay, so root 2 into root 3. Okay, now I can operate these two, and I may have written over here, it will be, this would be the answer then. Understood? Now let us consider another question, like say 5 root 7 into root 2 by root 14. Okay, my question is, I have to solve this one, 5 root 7 into root 2 by root 14. Now 5 into, this means what? 5 into root 7 into root 3. Now whenever in multiplication form, if it is given, we can individually we can multiply both the numbers and we can put the root also. Okay, so similarly here root 14 means what? I can write root 7 into root 2. Okay, so same terms in numerator and denominator will cancel each other, and my answer will become as 5. Understood? Now let us simplify another problem. Let 5 plus root 2 and root 5 minus root 2. Okay, I have been given root 5 plus root 2 into root 5 minus root 2. Now this one I can put it into a square minus b square formula, right? A square minus b square means what? A plus b into a minus b. So I can write directly, if I consider this as a, this as b, so I can write root 5 whole square minus root 2 whole square, which means what? 5. Okay, 5 minus 2, which means it will be 3. Root of square of any root over number is the number itself. Okay, the original number without the root. Okay, that will be the answer. So hence root 5 whole square means 5 and root 2 whole square means 2. So 5 minus 2 is 3. This is the answer. Now next, if I am asked, if I am given one number like 1 by root 3 and I am told to rationalize the denominator. Okay, rationalize the denominator. Rationalize means what? I have to convert one irrational number to an rational number. Now when I am given this type of questions, what will I do? I'll write the number, and as I'll apply that trick, that when I'm multiplying the same amount of irrational number to a irrational number, I'll get one rational number. That trick I'll be applying. But I just can't multiply a number, I just can't multiply that number with this number until and unless I have this root 3 in the numerator part also, so that such that when I cancel both the things, or when I divide, it will come as 1. Okay, and 1 into something will be 1 only. So what will I do? I'll consider root 3 by root 3. Okay, why this root 3 by root 3? I can't bring an extra thing over here. If I want to add, if I want to multiply root 3 in the denominator part, I need to multiply in the numerator part also. Okay, so now root 3 into root 3 becomes what? 3. So I can write, and 1 into root 3 will be root 3. So root 3 by 3. So see, I have changed one irrational number to an rational number. Okay, this is known as rationalizing the denominator. So now next, take a little harder problem. Okay, now suppose I'm given this one plus 2. Okay, this one plus 2, and I'm asked to rationalize the denominator. Okay, how will I do that? Now see, I need to change the denominator part. Okay, now the denominator is not just root 3, it is root 3 plus an add-on portion is there, that is plus 2. Now this total is a number, it is not only root 3. Okay, so to change this, again we will apply the same trick that we have been doing the last problem. I'll try to bring such a number such that this will change into a rational number. So I'll write 1 by root 3 plus 2. Okay, if this is A and this is B, we know that A square minus B square is equal to A plus B into A minus B. So using that formula only, I'll bring root 3 minus 2. Okay, similarly I have to multiply that term only with the numerator. Okay, now see, this one into this thing will be coming the same thing. So here what it will be, root 3 whole square minus 2 whole square. Why root 3 whole square? Because I have considered this as A and considered this as B. So A square minus B square. See, A square, A plus B into A minus B. Okay, so it will be root 3 minus 2 by 3 minus 4. Okay, so your answer will be minus root 3 minus 2, because 4 minus 3 minus 4 is minus 1. So root 3 minus 2, or we can say it as, we can just arrange it and say it as 2 minus root 3. This is how we do rationalizing of the denominator. Okay, now we will have a look on the laws of exponent on real numbers. Okay, so exponents and problem solving with powers and roots you have already learned in your previous classes. Okay, now let's see what are the laws. These things you have already learned, just a brush up. Okay, suppose A is a term which is having a power m, and another Again, A is a term with a different number of power it has got. So we can directly, instead of writing in this way, we can directly write the base and will be adding on the power. Okay, this operation can be done only when both the bases are same. Okay, I mean they are in multiplication form. Second thing is what? Suppose same base with power, different power, same base with different power but in division form. So here multiplication means addition, so division means subtraction. Okay. Third thing, suppose if my power is in this form, that is base to the power something and the whole term, okay, this whole term is to the power something. At that point of that type of problems, what we do, we multiply the powers. Okay, so it will be m into n. Okay, and suppose we have two different bases, okay, but the powers are same. Okay, so we can just club them together and we can raise the power. Okay, understood? Example of this, let's see. If I say 3 to the power 2 into 3 to the power 3, okay, we may write, instead of writing in this way, okay, this is in into form, okay, instead of this we can write 3 to the power m plus n, no? So 3 to the power 5, 2 plus 3. Okay, for this one let's see. Example, 3 to the power, suppose it is again same one, 3 to the power 2 by 3 to the power 3. Okay, what we can write, 3 to the power 2 minus 3, which is 3 to the power minus 1, which means 1 by 3. Okay, next one, example of this one, 3 to the power 2 to the power 3. Okay, 3 to the power 2, wait, 3 to the power 2 to the power 3. So we can write directly as 3 to the power 6. Okay, and the last one, suppose 2 to the power 3 and we have 3 to the power 3. We may write this as 3 into 2 is what? 6. 6 to the power 3. Understood? So applying this, we can solve various types of problem. Another thing, suppose I am given fifth one, suppose I am given n root a. Okay, what does this mean? This means a to the power 1 by n. Understood? Example, if I am given cube root of, suppose 27, okay, cube root of 27. This means 27 to the power 1 by 3. Okay, 27 to the power 1 by 3. Now this one, how we can write? We know that 27 means what? 3 into 3, 9. 9 into 3 is 27, right? So we can directly write 3 cube to the power 1 by 3. Okay, which means what? 3 into 1 by 3 from here. Okay, if the whole thing is in power or something, we just multiply. Okay, similarly we can do this. Now when we are multiplying, we can just cancel it off and we may write it as 3. Understood? So this is for the laws of exponent for real numbers. Now another thing we may say that suppose it is given as any number is given, the power is given in division form, like m by n. This means now n is in denominator, whatever is there in the denominator, that will be root over of the base. Okay, to the power what will be in the numerator that we are going to write. For example, suppose if I am given 3 2 by 3, this can be expressed as 3 is in denominator, 3 one thing you must understand, this 3 I am writing, this doesn't mean that 3 into root 3, this means cube root of 3. Okay, this means cube root of 3 to the power 2. Understood? So we have come to the end of this today's lecture session. So at the end I have few questions for you. First thing is, represent root 3.2 on number line. Okay, the process that I have already shown you, that drawing an arc, taking one unit. Okay, first you have to take 3.2, then 1 unit you have to take, and taking 3.2 plus 1 as diameter of a circle, you have to draw one arc. Okay, and perpendicular line should be taken, and from there you have to find out this root 3.2, and from there you will just draw one another arc on the number line so that you get this one. The previous general technique I have shown you, the same thing you will be applying and you will be doing this. Okay, second, simplify to see two things are given, two terms are given, and you need to simplify. Okay, and the technique that I've shown you, okay, a square minus b square, that formula you will keep in mind, and when you get similar kinds of powers, you need to club them together, and if you do not get them, just leave as it is. Okay, third thing is the rationalizing the denominator, which means you have to just overcome this irrational denominator and you have to bring rational denominator. And how to do that? All the points that I have shown, I have told you previously, that when you multiply one irrational number, a square minus b square, that formula, like if you consider this as a, this as b, it is given in form of a minus b, so you need to bring one a plus b, and when you are bringing a plus b in the denominator, you need to bring that in the numerator also. So in that way you have to solve these two problems. And the last one is the simplification. Exponent form it is given, so you need to just break the terms and you have to show accordingly. Okay, and here also similarly you have to do. See, here 9 is given. 9 means what? 3. If you can bring that, if you can reduce the base, okay, 9 you can reduce the base, 4 also you can reduce the base, and similarly you can solve the problem. So this is what you have for the assignment 3. Okay, hope you have understood the problems. See you in the next video.